Okay. So the next concept which we are discussing is about radioactivity. And in radioactivity, first of all, we have to discuss about nuclear stability. So nucleus will be stable depending on two factors. What are the two factors? First one is, so binding energy per nucleon. Okay. So if binding energy per nucleon, if it is maximum, then nucleus will be stable. Already we have discussed this one, Nama. For example, if you take binding energy per nucleon of iron, okay, then it is nearly 8.8 million electron volts. So this is the binding energy of iron. It means that the binding energy of iron, this is the maximum out of all the 118 elements we have. So therefore iron is considered to be the most stable element. So therefore if BEN is maximum, definitely nucleus will be stable. And the second fact is neutron proton ratio. Okay, ma? Neutron proton ratio. Okay. So if or I will say so in elements whose Z value is less than 20 or less than or equal to 20, clear ma? So number of protons will be equal to number of neutrons. Okay. So for elements whose atomic number is less than 20, clear? So the number of protons and number of neutrons, they are almost same. So but for elements whose Z value is greater than 20, clear ma? So number of neutrons will be greater than number of protons. Okay. So neutron number will become very large when compared to number of protons. Okay. So this is again to obtain stability of the nucleus. So how the increase of neutrons is accountable for increasing the number of protons, let us see. Okay, ma? So if number of neutrons increases, if number of neutrons increase, okay, ma? They come in between protons, and thus the force of repulsion is reduced. Okay. So if a force of repulsion reduces, automatically nucleus will become stable. So nucleus tends to be unstable only because of repulsion between the protons only, no? So therefore these neutrons, what they will do, they will come in between the proton. This is a neutron, so this is a proton, and this is another proton. So as the distance between the protons increases, automatically the force of repulsion between them also reduces. So this is one factor. Okay. For elements whose Z is greater than 82, it means a plumbum. Elements with the atomic number greater than 82, that is after lead. So even the number of protons are very large, then the number of protons are also very large. So Z number 82 means what? 82 protons are there. It means even the number of neutrons are very large, so nucleus cannot be stable. Clear, Nama? So therefore we write for Z greater than 82, even the number of neutrons are very large, okay, but still the nucleus will become unstable. Okay, ma? So therefore this results in an activity called as radioactivity. So therefore the elements above atomic number 82, that is after plumbum, so even the number of neutrons are very large, but still they are unstable. So these nucleus, they will try to become stable by emitting alpha, beta and gamma radiations. Are you able to understand, ma? So that concept is nothing but radioactivity. So let us. So therefore what is meant by radioactivity? Okay, ma? So radioactivity, how can I define? Okay. So elements after plumbum, lead 82, okay, ma? Try to become stable by emitting alpha, beta and gamma particles. Okay, ma? So this continues until they attain a stable configuration. And what is the stable configuration? Definitely plumbum 82 is the stable configuration. Okay, ma? So any radioactive element, why it is emitting alpha, beta and gamma radiations? It is emitting these radiations only to become stable. That's it. Okay. So therefore, for example, if you take uranium 92-238, what is the meaning of uranium 92-238? Ma? It means 92 protons are present and 238 minus 92 neutrons are present. Okay. So neutrons are very large when compared to protons, but still uranium is not stable and it tries to become stable by emitting alpha, beta and gamma radiations. Okay, ma? Now let us have a small discussion on what is this alpha, beta and gamma particles they are made up of. Okay. So what is meant by alpha particle? Alpha particle means it is helium nucleus. So nucleus of helium is nothing but alpha. We know that atomic number of helium is 2, no? It means there are 2 electrons revolving around the nucleus of alpha particle. So if I remove those 2 electrons, clear? If both the electrons are removed, then what I am left with? I am left with only helium nucleus. So that helium nucleus itself is called as alpha particle. So therefore alpha particle can be written as helium-2-4. We know its atomic number is 2. It means number of protons will be 2. And what is the mass number? Mass number is 4 because there are 2 protons and there are 2 neutrons. Clear, no? And because we have removed 2 electrons from this one, only protons are present. So therefore the charge of helium nucleus will be 2 plus. Okay. Therefore it is a positively charged particle. Okay, ma? So what kind of particle is this? This is a positively charged particle. Alpha particle is a positively charged particle. Clear, no? So therefore, if it is a charged particle, then definitely it means that it will be deflected by electric field also, it will be deflected by magnetic field also. We know that the charged particles, they will be deflected by electric field as well as magnetic field also. Okay, that we will discuss later. Okay. Then if I study about a beta particle, okay, ma? And one more property of alpha particle is, if alpha particle is emitted, clear, ma? Then proton number reduces by 2 units and mass number reduces by 4 units. Okay, ma? So this is one point which you should remember. So from the nucleus, if an alpha particle is ejected, it means alpha particle is made up of 2 protons and 2 neutrons. So definitely proton number reduces by 2. So what is meant by proton number reduces by 2? It means atomic number of that element also reduces. It means if all the chemical properties that depends on atomic number only, no, ma? It means that if alpha particle is emitted, so this radioactive element, it converts into another radioactive element because proton number is reduced here. Are you able to understand? So therefore proton number reduces by 2 units, and because it has 2 protons and 2 neutrons, mass number also reduces by 4 units. Clear, no? Then we study about beta particle. Okay. What is beta particle? It is just like an electron. Okay, ma? Beta particle is just like an electron itself. But the point is that this electron, it is not the electron which is revolving around the nucleus. No. Okay, ma? This electron would have been formed inside the nucleus. It is not that electron which is revolving around the nucleus. So therefore what we write, therefore it is produced inside the nucleus. Okay, but it has same properties of that of electron. So its mass is also same as that of electron. Clear? Its charge is also same as that of electron. Okay. Now this beta particle, definitely it is a charged particle. It is a negatively charged particle. So this particle also will be deflected by both magnetic fields as well as electric fields. Okay, ma? And how this beta particle is created? Neutron, it gets split into proton plus beta particle. So this is what is happening actually. Okay, ma? So inside the what you call beta particle, neutron, it converts into a proton and it converts into a beta particle. Clear, nama? So therefore neutron is converting into proton. So mass number does not change because the mass of neutron and proton is almost the same. Okay, so there is no change in mass number. But one neutral particle, it has converted into a charged particle. Okay, so definitely if number of proton is increasing, it means if one beta particle is emitted, Z value increases by 1. Okay, ma? So what is meant by Z value? Atomic number increases by 1 here. So that is the property of beta emission. So therefore write down. Okay, therefore what we write? Okay, ma? Therefore we write, if beta particle is emitted, then what happens? Mass number does not change. Mass number does not change. There is no change in mass number. Okay, ma? But proton number increases by 1. Okay, ma? 1 unit. 1 means 1 unit. Proton number increases by 1 unit. Okay. Then what about the emission of gamma particle? Let us see. Okay. Gamma particle. So gamma particle is nothing but it is a photon. It is a packet of electromagnetic energy. Are you able to understand, ma? See, ma, whenever alpha and beta particles, when they are emitted, nucleus may be in excited state. Nucleus may be present in excited state. So again, to come to ground state, so this alpha and beta particle, after the emission of alpha and beta particle, to return to ground state, nucleus may emit an photon. That photon is nothing but a gamma particle. Are you able to understand? So therefore, when alpha or beta is emitted, okay, ma, then nucleus may be in excited state. Okay, so when it is in excited state, it tries to come to ground state by emitting what? By emitting a photon, or you can call it as a gamma particle. Okay, so because this is a photon, this is an uncharged particle. Okay, ma? It doesn't have any kind of charge. Positive charge is not there, negative charge also is not present. Because it is not a charged particle, it is not deflected by magnetic field, it is not deflected by electric field also. And when gamma particle is emitted, there is no change in mass number, there is no change in proton number also. Clear, nama? So make a note of that point. What is the note point I have to write? So there is no change either in mass number or atomic number. Okay, ma? And remaining properties of this alpha, beta and gamma particles we will draw in the next slide. Okay, ma? Study about the properties of alpha, beta and gamma particles, ma? Okay, so see. So first property, identity. What is meant by identity? These particles, they are made up of what? That is called as identity. Clear, nama? So alpha particles, already we studied, they are helium nuclei, nama? When you remove 2 electrons from the helium atom, then you have only nucleus, no? That nucleus itself is called as alpha particle. Clear? So therefore it is a helium 2 and 4. Atomic number is 2, mass number is 4. That is an alpha particle. Clear, nama? And beta particle, they are electrons. Beta particles, they are nothing but electrons. But these are not the electrons that were revolving. So around the nucleus, electrons will be revolving. Electrons kadi. These are the electrons which are created inside the nucleus. Nucleus lopala form attayi. But they are just like electrons only. Mass is also same, charge is also same. But they are not the electrons which are revolving around the nucleus. Nucleus chuttu tirugutu untayi avi kadi. So they are formed inside the nucleus. Nucleus lopala form attayi. Clear, nama? So therefore here you can write not revolving electrons. They are not the electrons which are revolving. Okay, ma? And beta particle. What is meant by beta particle? It is radiation energy, light energy, or you can call it as energy like X-rays. Are you able to understand now? So we know radiation. No? So gamma particles is not matter. It is just radiation. So this is the contents of this alpha, beta and gamma particles. Charge. So what is the charge of alpha particle? See, from helium atom, if you remove 2 electrons, then what will be the charge of helium? 2 plus, no? If you remove 1 electron, charge will be 1 plus. If you remove 2 electrons, charge will be 2 plus. So therefore charge of helium will be 2 times the charge of electron. Electron charge is negative, 1 negative. But charge of alpha particles is 2 positive. So I can write He 2 plus. So this is the charge of alpha particle. Clear now? And beta particle, it is just like electron, already we said, no? So therefore its charge will be equal to the charge of electron itself. Okay? And gamma particle is just a radiation, source of radiation, energy. So therefore this does not have any charge. So out of alpha, beta and gamma, alpha and beta, they are charged particles and they are matter. But gamma particle, it is not a particle, it is radiation. Or you can say they are made up of particles called photons. Understood, no? Okay. Similarly, penetration range. So how deeply they can penetrate into matter, that is called as penetration capacity. Okay, see ma'am. Alpha particle is a very heavy particle. No? Alpha particle is a very, very heavy particle. So therefore, it cannot penetrate into matter. Matter lo kadi penetrate avaledu. For example, if I incident alpha particle on paper, it cannot pass into paper also. Paper lo kuda vellaladu. Which one? Alpha particle. Clear now? And in air, it can enter into air only up to a distance of 5 centimeters of air. Air lopala aithe just 5 centimeters velthe. So therefore, penetration capacity of alpha particle is very less. Clear now? Whereas if you see the penetration capacity of beta particle, beta means electron, no? Very small. So it has good penetration capacity. It can enter into 1 or 2 papers also. And in air also it can travel up to 500 centimeters. Are you able to understand now? If you release an alpha particle into air, beta particle, it can travel up to 500 centimeters through air. Okay? And when it is incident through matter means paper or like that, then it can enter 10 millimeter. 10 millimeter means 1 centimeter of matter it can enter. Which one? Beta particle. Then what about gamma particle? This is radiation, no? This is radiation, X-rays. Okay? So therefore its penetration capacity will be very large. So it can travel through several centimeters also in lead metal. If you take lead metal, it can enter into several centimeters of lead metal also. Okay? Next, fluorescence. What is meant by fluorescence? If any particle goes and strikes any fluorescent surface, it will give a bright colored spot. No? That bright colored spot is called as fluorescence. Are you able to understand? So in gold foil experiment, Rutherford, what he has done is he has taken a zinc sulfide screen. And on that zinc sulfide screen, if this alpha particles go and strike, then a bright spot will be created there temporarily. That property is called as fluorescence. Clear now? So now let us see the fluorescence of alpha, beta and gamma. Can cause fluorescence only on some substances. So when alpha particles strike some substances like zinc sulfide, then it can create a bright spot. Okay, ma? And gamma, beta particles, definitely they can cause fluorescence. And gamma particles fluorescence is very, very, very less. Okay, that's it. Ionizing power. What is meant by ionizing power, ma? Ionizing power means SIMA. So the ability to dislocate electrons from another atom is called as ionizing capacity. For example, if alpha particles are released into the atmosphere, they are very heavy particles, and size of alpha particle is also very large. So when it comes into contact with another atom, for example like oxygen or nitrogen in air, then easily it can dislocate the electrons which are present in either oxygen or nitrogen. Okay, ma? Andalo na electrons ne bayitiki teesestunadi because it is a very heavy particle. Okay, ma? Very easily it can remove electrons from other atoms. That property is called what? That property is called as ionizing power. And it is a very large particle, and comparatively it travels so slowly also. So whatever atoms it find in its path, it will dislocate electrons from that atom. Where atoms nunchi electrons ni bayitiki teestundi. Clear ma? That property is called as ionizing power. And ionizing power of alpha is very large. This is the largest. Penetration power is the least, whereas ionizing power is the highest. And when compared to alpha, what is the ionizing power of beta? Beta is just electron. So therefore its ionizing capacity will be very less because its energy also is very less. Okay, ma? So how much it is? 1 by 100th times of alpha particle. 1 and very less. And when compared to gamma, and gamma is still 1 by 100 times less than beta. It means 1 by 10,000 times less than alpha particle. Are you able to understand? Ionizing power of gamma particle, it is 1 by 100th times less than beta. Beta is already 1 by 100 times less than alpha, no? So what is the ionizing power of gamma? 1 by 100 into 1 by 100? 1 by 10,000 times lesser when compared to alpha particle. So like this also questions can be asked. Next, speed. Less than speed of light, less than speed of light. But this is radiation, no? It exactly travels with the speed of light. Radiation. Every radiation in vacuum, it travels with the speed of light, whether it is alpha, beta, gamma, X-rays, UV rays, visible spectrum, whatever it may be, every radiation has so much speed, 3 into 10 power 8 meter per second. Clear, no? Next, effect of electric and magnetic fields. So in the path of alpha, beta and gamma rays, if you place electric field and magnetic field, then what will happen? See, every charged particle will deviate when electric fields and magnetic fields when they are placed. Are you able to understand? And out of alpha, beta and gamma, which are the charged particles? Alpha and beta, they are charged. Which is a neutral particle? Radiation, gamma. It is not charged, no? So gamma particle doesn't deviate, whereas alpha and beta, they will deviate from their path. Okay. So deflected both by both fields. This is also deflected by both fields, but here you cannot find any deflection. Okay. Next, mass. Mass is exactly equal to mass of helium nucleus, because alpha particle is nothing but helium nucleus, and this is exactly electron, so mass of electron, and it doesn't have any rest mass. Photon does not have any rest mass. Photon cannot be in rest position, first of all. Radiation is made up of photon, according to Planck's quantum theory. Total radiation is made up of photons, and photons cannot be in rest position. Okay, so zero rest mass. But when they are in movement, they have momentum, no? When photons are movement, when light energy is moving, it has momentum. And when it has momentum, it has mass. అర్థమవుతుంది కదా? మూమెంట్లో ఉన్నప్పుడు గామా పార్టికల్కి మాస్ ఉంటుంది, రెస్ట్లో ఉండదు కాబట్టి మాసే ఉంటుంది. క్లియర్? దట్స్ ఇట్. సో నెక్స్ట్, ఎనర్జీ. సో ఎనర్జీ is approximately equal to 6 million electron volts for alpha, approximately 1 million electron for beta, and it is 0.01 million electron for gamma. So which is the least energetic particle? Gamma is the least energetic particle, and highest energetic particle is alpha particle. Physics. So most of the questions may be theoretical bits also, rather than problems. Okay, theory bits also there is a good chance of getting asked in modern physics. So listen to the concept very carefully. So see, rules of radioactive decay. So what are the rules followed by radioactivity for giving this alpha, beta and gamma particles? Clear, ma? So Rutherford and his associates, they gave some laws. They gave some rules of what is the process in which this radioactivity will take place. Clear? So first one which they said is unaffected by temperature, pressure, okay, ma, or external factors. Okay, ma? It is not at all affected by, already we discussed this point, you know. So whatever may be the temperature of radioactive substances and how much pressure you put on them, and if you apply any external force, they are not affected by all of them. So when they release alpha, when they release beta, when they release gamma, nobody knows. Are you able to understand, ma? So భయంకరమైన మూడు మనుషులు అన్నమాట, ఎప్పుడు ఎలా బిహేవ్ చేస్తారో దానికి తెలియదు. So that is the first property. Second one is, okay, ma? So either alpha or beta only is released. Okay, ma? So what is meant by either alpha or only beta is released? It means when alpha is released, beta is not released, and when beta is released, alpha is not released. Either alpha or beta. And gamma is a different condition. Gamma is the only radiation number. So when either alpha or beta, when they are released, and when the nucleus, when it is in excited state, then it comes to normal state by giving gamma radiation. Are you able to understand, ma? ఈ రెండు ఎమిట్ చేసినప్పుడు ఆవేశంలో ఉంటుంది అన్నమాట, in excited state. So to reduce that excited state, it will give some more energy in the form of radiation. Okay, and 2 alphas or 2 betas are also not released. Okay, ma? 2 alphas are also, they are not released. Similarly, 2 betas also, they are never released. Are you able to understand, ma? So alpha and alpha, after an alpha particle is released, again one more alpha cannot be released. Similarly, 2 alphas at same time also cannot be released. Are you able to understand? This is another property. Okay, so third property is when alpha particle is released, when alpha particle is released, okay ma, then what happens is atomic number reduces by 2 and mass number reduces by 4, okay ma? Because helium nucleus, it will have mass number 4, no? What is the mass of helium? 4 atomic mass units. And what will be its proton number? 2 protons will be there. So when an alpha particle is released, mass number reduces by 4, atomic number reduces by 2, okay? If I take one example, uranium-92-238, okay ma? It converts into thorium-90-234 by emitting one alpha particle. So this is what will happen. Understood now? So element is completely changing. Uranium has converted into thorium. Atomic number of uranium 92, thorium 90, mass number 238, but mass number of thorium is 234. So mass number reduced by 4, atomic number reduced by 2. So that is what will happen. Okay ma? Fourth one is when beta particle is released, okay, then atomic number increases by 1. Atomic number increases by 1 and mass number does not change. Mass number does not change. Okay. For example, carbon 614, it converts into nitrogen 714 plus 1 beta particle. So this is what will happen. Okay, ma? Carbon 614 it is a radioactive isotope. Carbon 614, it is not so stable. It is very unstable. Okay, ma? So it tries to attain stability by emitting one beta particle. Okay. So atomic number 6, but atomic number of nitrogen 7. Clear now? So atomic number increased, no? Clear? But what about mass number? Mass number is not changing. What is the reason for this one? Here we will write. Reason is that neutron, it gets split into proton plus beta particle. This is what will happen. So out of many neutrons, one neutron, it splits into what? Neutron will split into proton and a beta particle. This is a positively charged particle and this is a negatively charged particle. Positive and negative, they will become neutral, no? So therefore neutron is a neutral particle. It splits into proton as well as a beta particle. Okay, ma? So neutron atomic mass units is 1, no? Mass of neutron is 1 AMU approximately. 1.0083 something will be there, but approximately equal to 1 AMU. And mass of proton is also approximately 1 AMU, 1.0078, almost equal to 1 AMU. So mass number is not changing because 1 AMU is converted into 1 AMU. Mass number never changes. Okay, ma? But definitely one neutron has disappeared and one proton has formed. Adi jarigindi kada? Oka neutron mayమైపోయింది. దాని ప్లేస్లో ఒక proton వచ్చింది. But whatever it may be, mass number does not change. Mass number is number of protons and number of neutrons. Mass number lo marpu ledhu kada. Always it is constant. So 14 remains to be 14. Okay. And this extra particle, beta particle, which is released, that is released into the atmosphere. Are you able to understand, ma? Make a note up to here. Okay, ma? So understood now what is happening, why mass number is not changing but proton number is increasing, ma? So one proton has become extra, no? So proton number increases by 1. But mass number is not changing because neutron only it is converting into a proton. So this is what happens in the case of beta particle. Okay. Next, fifth one. When alpha or beta is released, okay, ma? And when nucleus is in excited state, then it comes to ground state. Ground state means normal state, ma? By emitting gamma radiation. Okay, ma? That is in the form of photon. It will release the extra energy and it comes to ground state. Okay. One more point is that, okay, sixth one. So the rate of disintegration the rate of disintegration is dependent on initial number of atoms not disintegrated or undisintegrated. What is the meaning of this statement, ma? So how many atoms are disintegrating per second? Disintegration means what? Either the emission of alpha or beta is called as disintegration. Are you able to understand, ma? And how many atoms are disintegrating per second? It depends on what? It depends on how many atoms are present which are not decayed, which are undecayed. Are you able to understand? If there are only 100 atoms, very few atoms will disintegrate. If there are 1000 atoms, more atoms will disintegrate. If there are 10,000 atoms, some more atoms will disintegrate. This is understandable, no? Konni atoms unte disintegration kuda konchame untundi. If there are more atoms, more disintegrations can happen. Okay? So these are some of the laws which are given by Rutherford and his associates. Understood, Nama? Make it note. Okay, ma? So see. So next, what we are studying, what was the last statement we have written in Rutherford's laws? We have written that rate of disintegration depends on initial number of undisintegrated atoms. This is what we have studied now. So that statement, we will try to derive some mathematical conclusions of that one. Okay, ma? So see. So rate of disintegration depends on initial number of undecayed atoms. If more number of atoms are present which have not released alpha, beta or gamma, then rate of disintegration, rate of emission of alpha, beta and gamma also will be greater. Are you able to understand? So therefore rate of disintegration, how can I write? Rate of disintegration, how can I write mathematical, ma? Minus dN divided by dt. I can write like this. Minus means the number of atoms are decreasing. Okay, ma? Number of atoms which are undecayed, they are reducing. Okay, because when they start emitting alpha, beta and gamma, more number of atoms are disintegrating. No? It means the number of atoms left for disintegration, they are reducing continuously. Okay, what is meant by dN? Change in number of atoms which are decaying. dt means change in time. So rate of disintegration minus dN by dt depends on what? It depends on n. That's all. It depends on number of atoms which are undecayed. What is meant by n here? Number of atoms undecayed, which have not decayed still. So if there are more atoms not decayed, then rate of disintegration also will be greater. So what is meant by n here? N means number of atoms left undecayed, which have still not decayed. It has not emitted one alpha also, one beta also, or one gamma also. Okay, then the rate of disintegration is directly proportional to n. So minus dN by dt can be written as lambda into n, where lambda is a constant. To remove a proportionality symbol, I have to write a constant. And this lambda is called as decay constant. Okay, ma? This is called as decay constant. Okay, and this decay constant, it varies from material to material. Okay, no, sir. So therefore I will do some manipulations here. Ma? So dN by n is equals to lambda into dt. Okay, so just this n I have taken to this side, dt I have taken to the other side. Then I have dN, no? So that, therefore what I will do is I will integrate on both sides. Okay, so when I integrate on both sides, what I will get? So minus I will take to this side, and here I will write a plus. So therefore, so log to the base e of n is equals to minus lambda into t plus n. So this is what I will get, or instead of n I will write k. Okay, so this is the method of integration. See here, differentiation of log n is 1 by n. Differentiation of log x is how much? 1 by x. So integration of 1 by n will become log n, because integration and differentiation, they are opposite processes. No? Okay, ma? So differentiation of log x, 1 by x. Integration of 1 by x dx, log x. Okay, and integration of dt will become t. Lambda is a constant. Okay, and when I integrate, there should be some constant values in the initial conditions, and those constant values are written by k here. So these are the rules of integration. Are you able to understand? Ma? So see here, integration of minus lambda into dt. Lambda is a constant, no? I will take out of integration. So integration of dt, integration and differentiation, they will get cancelled, no? So minus lambda into t. This is what I will get. but in the initial conditions also may be present. So after every integration you have to write a constant. Are you able to understand, ma? So that constant I am taking to be K. Now see. Now let us see how we can further proceed here. See, ma. So if T is equal to T naught, what is meant by T is equal to T naught? So when I am taking initial time, that is when I started observation, that time is called as initial time, no? And that time I will call it to be 0. Okay, that is when I started observation, from there only time will start, no? So time is 0. So if I take a time 0, then n will become n naught, no? What is meant by n is equal to n naught? The number of atoms which are left for undecayed, that is equal to initial number of atoms left for undecayed when I started observation. Okay, n means what? Number of atoms left undecayed. N naught means that is also number of atoms left undecayed when I started observation. Nenu observation start chesinappudu the number of atoms present were n naught. Understood, no? Now substitute all these values here. Therefore I can write log, instead of n I can write n naught, no, because initial number of atoms is n naught base to the e. So minus lambda into time is 0, no? Time is 0 plus k. Okay, lambda into 0, 0. Therefore what is k value I got? K value is log to the base e n naught. This is k value. So therefore I can take this k value and substitute here. Okay, so let it be my first equation. So substituting k in 1. Therefore what I will get? I will get log n to the base e is equals to minus lambda into t plus, instead of k what I can write? Log n naught to the base e. This is what I can write. అర్థమవుతుందా ఎలా ప్రొసీడ్ అవుతున్నామో? Okay, ma? These calculations you have to do 1 or 2 times. Then you can understand actually what is happening here. Are you able to understand? Now see. So take all log values on one side, ma. So log n to the base e minus log n naught to the base e is equals to minus lambda into t. So log m minus log n, log m by n. That is a rule, no? So therefore log to the base e n divided by n naught is equals to minus lambda into t. Okay, ma? So I got relation up to here. Now what I will do, I will apply logarithms on both sides. So applying log on both sides. Then what I will get? Then I will get n divided by n naught is equals to e power minus lambda into t. So this is the relation which I will get. Okay, ma? So applying log rules on both sides. Okay, see ma, here n by n naught e power minus lambda t can be converted into of this form also when you apply logarithms. Are you able to understand? These are the rules of logarithms. ఇప్పుడు నేను అవన్నీ ఎక్స్ప్లెయిన్ చేయాలంటే కష్టము. You try to study afterwards. Okay, so this equation can be converted into this equation. So therefore n can be written as n naught e power minus lambda into t. So this is an important relation. Are you able to understand? So what is meant by n here? Number of atoms left undecayed after a time of t. T is interval of time, no? And what is meant by n naught? Before that time, how many atoms were left for undecayed? That is when you started observation. Okay, ma? So for example, if I take this atoms is 100, this atoms is some 60. What is meant by 60 and 100? When you started observation, number of atoms left undecayed were 100. And after a time of t, now how many atoms are there? Only 60 atoms are there. It means so 40 atoms have disintegrated. Either they have released alpha or either they have released beta. That is the meaning of this equation. అర్థమవుతుంది కదమ్మా? So n is equals to n naught e power minus lambda into t. Very important equation to calculate the number of atoms which are left undecayed after a time of t. Okay, ma? So therefore what is n here? Number of atoms left undecayed after a time of t. That is called as the equation of rate of disintegration. Understood, Nama, what is happening? Make it out. Then it is very easy. Okay, now see. So we will study next about decay constant. Okay. So already we have studied that radioactive disintegration is directly proportional to number of atoms, Nama. Radioactive disintegration is directly proportional to number of initial atoms which are left undecayed. Okay. So therefore, to remove this proportionality symbol, I have to write a constant, and that constant itself is called as decay constant. So therefore, lambda can be written as minus dn by dt divided by n. This n comes to this side. This is the equation. Now, how can you give a statement for lambda by looking at this statement? By looking at this equation, decay constant ki statement ela rastaru cheppandi. What is meant by decay constant? Come on. Dn by dt is nothing but the number of disintegrations or rate of disintegration. Rate of disintegration means what? How many atoms are disintegrating per second? dt means per second. Okay, ma? How many atoms are disintegrating per second divided by original number of atoms left undecayed. That is called as lambda value. Okay, ma? If lambda value of a particular radioactive substance is greater, it means what? For example, uranium radioactive substance, carbon 614 radioactive substance, thorium radioactive substance. Are you able to understand? So in all of them, consider the lambda value of one radioactive substance is greater. Then what do you understand? If lambda value is greater, what do you understand? So look at the equation ni batti cheppali. Total definition, how can you say? For example, I am comparing two radioactive substances. For one radioactive substance, I have understood that its lambda value is greater. What do you understand? No, what I understand is that for same number of atoms, the disintegrations will be greater. Okay? For example, you take a radioactive substance X, okay, ma? And Y. Two radioactive substances I am taking. Okay, so here I have initially 1000 atoms, here also I have 1000 atoms ready for disintegration. Disintegrate avvataniki ready ga unnai. So X 1000 atoms, Y also 1000 atoms. You can say this is uranium, this is thorium, anything. Okay, ma? So out of 1000 atoms, 5 atoms are disintegrating per second. For every 1 second, how many atoms are disintegrating? 5 atoms are disintegrating. Okay, ma? But in Y material, only 1 atom is disintegrating per second. Okay, then whose lambda value is greater? Your lambda value account? Definitely X. Why? Because 5 atoms per second is nothing but dn by dt, no? And n value is same, n value is 1000. Number of initial atoms, that is constant. But number of disintegrations per second, if it is greater, therefore we can say its lambda value is also greater. That is meant by lambda. Okay, ma? So for the number of available atoms, how many disintegrations are happening, that ratio is called as lambda. Okay? కొన్ని atoms కి ఎక్కువ disintegrations జరుగుతున్నాయి అనుకోండి, it means lambda value is greater. Clear? Right on. Okay, ma? So therefore, how can I define lambda? The number of disintegrations to the ratio of available atoms undecayed is called lambda, is called as decay constant. So you write this example also. Okay, ma? So what is the lambda value of X here? 5 divided by 1000. Clear now? And what is the lambda value of Y here? 1 divided by 1000. 5 disintegrations out of 1000. 1 disintegration out of 1000. Which one is greater? Definitely lambda X is greater. Understood now? That is called as the rate or the decay constant. Understood now? Okay. And if I want to do some more mathematics, I can do. Okay, ma? So see. So we know that n is equals to n naught e power minus lambda into t. This equation already we have derived, ma? The equation of radioactive disintegration. N is equals to n naught e power minus lambda into t. Okay. Now I will do one thing. Let us take lambda is equals to 1 by t. Just I will see what will happen. Lambda value, how much I am taking? 1 by t. Time taken. Then substitute there. Then n is equals to n naught e power minus, instead of lambda I will write 1 by t, and t is already present. Okay. So t and t will get cancelled, then what I will get, n is equal to n naught e power minus 1. This is what I will get. Clear number? So therefore n naught by e is equal to n. So n is equals to n naught divided by e, and what is e value? E value is 2.718 approximately. Okay, ma? So therefore it is how much, ma? 0.37 n naught. So therefore n is equals to 0.37 n naught. So by doing this calculation, what do you understand? What do you understand? చెప్పండి. ఎందెందో చేసుకుని లాస్ట్కి ఎందెందో వచ్చింది. మీకేం అర్థమైంది చెప్పండి. వాట్ హ్యావ్ యూ అండర్స్టాండ్? జయంతి చూస్తాను ఏంది ఇది గ్రహాంతరవాసి జీవిలాగా ఉన్నట్లన్నీ ఫేస్ పెట్టిన తర్వాత. శివ, lambda I have taken reciprocal of time, no? Lambda I have taken to be reciprocal of time. T is nothing but time only, no? After some instant of time. So when I substituted these values, I got this value, n naught by e is n naught divided e value 2.718. It is 0.37 times of n naught. It means that n naught is the number of atoms initially when I started observation, no? And n value is 0.37 times of n naught. It means 100 minus 37, how much, ma? 63. 63% of the atoms have disintegrated. What is the meaning of this one, no? N is equal to 0.37 n naught. It means only 37% of the atoms are still ready for disintegration. It means already how many of them have disintegrated? 63% have already disintegrated. Okay, ma? So therefore lambda is defined as that reciprocal of time taken, reciprocal only, reciprocal of time taken for 63% of the atoms to disintegrate, or for 37% of the atoms to be still ready for disintegration. That reciprocal of time is called as lambda. Time taken kaadu, reciprocal of time taken, for which 63% of the atoms should be disintegrated. 100లో ఎన్ని ఐటమ్స్ లేచిపోవడం అంటే అది కదా. How many atoms should disintegrate? 63% should disintegrate, and only 37% should be still present. That reciprocal of time taken is nothing but lambda. Understood, Nama? Make a note. So therefore what I write? Okay, therefore what I write is lambda is the reciprocal of time taken for 63% of atoms to disintegrate. Okay, or time taken, reciprocal of time taken, reciprocal of time taken for what? For 37% of atoms still ready for disintegration. Disintegration and decaying both are same. Are you able to understand? So that amount of time taken is called as lambda. అర్థమవుతుంది కదా? That's it.